Today's podcast sponsor is Huber Engineered Woods, and I want to talk to you about zip sheathing and why we use zip sheathing. I know you've heard me talk about it on the podcast before, but I thought let's just lay it out in the simplest of forms. Number one, when I install it properly, I tape the seams, I liquid flash the seams, I manage for water with my windows. I use their products. I don't have to worry about water. There are times when we install drywall inside of a house and we don't have cladding on the outside because I know Zip System is going to be waterproof. So that's number one. Number two, I can manage for air. So using Zip System sheathing on the walls, my last 5 houses we built were all below passive house levels of air leakage. They were all below that 0.6 ACH50. And we're not putting that much effort into air sealing. We're just making sure that we tape well, which we manage for water, we manage for air. And the last 5 houses that I built all had Zip-R, because that continuous insulation that comes adhered to the back of my zip sheathing that I'm already putting up and installing, now I have continuous R value that I get the whole R6 or the R9 or R12, whatever it is. I don't see building any other way. It works for us. It can work for you. Make sure you go to huberwood.com and check them out. And Huber, thanks for sponsoring the podcast.
Pete Yost here for the Unbuild It podcast. I'm your host for this episode. I'm here with my good buddies.
Peter. Oh, I'm Steve Basic.
That was a quick one. Let's get those mistakes out of the way.
Get them out of the way.
And I'm Jake Bruton.
How do you know it was a mistake?
It was a great way to start off my hosting the Unbuild It podcast. So the topic this time around is how to build a house without a floor. And I'm as curious as all of you are as to how you actually accomplish this. So I didn't choose this topic. How do you build a house without a floor?
It's all about levitation.
It's all about levitation.
It's all about your levitation skills.
This involves seances and things like that.
It can. In the spirit of Halloween coming, we can get crazy here.
Somebody doesn't know when this is publishing, so the Halloween coming mark it's coming next year.
Well, it could. Halloween is always coming.
It is.
Even
unless it's
November
today.
1st, Halloween is still coming. So, thank you, YouTube listeners. Thank you for being on my side. This guy's always trying to beat me up.
So let's talk the reason that we would want to build a house without a floor, as we said. We're not building a house without a floor. Let's start there. We're talking about...
that's the trick.
We're talking about removing the concrete slab from a slab-on-grade home. That's what we're actually talking about. Or from a basement with a concrete slab. So we're talking about getting rid of some of the concrete in the built environment. And there's multiple reasons that we could do that, right? Number one, an easy argument is concrete's fairly bad for the environment from a global warming potential number. There's a lot that goes into it. The Portland process is even worse than the quarrying and delivery process. Number two, concrete floors are cold. Even if they're insulated and totally in the environment, the emissivity of the material, just like your stone countertops are cold, it's not as comfortable as warm carpet or cork or something like that. And from a comfort perspective, again, we can then say, well, they're hard too. If you're going to stand at the kitchen sink and do dishes, it might be uncomfortable. It might, if you're standing at the stove, whatever it is, or if you're like myself and you just stand in front of the refrigerator with the door open long enough that your legs get tired trying to figure out what you want to eat, it could be uncomfortable. What other reasons might we not want to put a concrete slab in? It's hard to repair things underneath of it, right? We'd have to cut out concrete to get to a plumbing error. It might be easier a different way to get to it. I mean, obviously, we're not building the whole house with the idea that we're going to repair or replace or remodel, but it's something to consider.
Yeah, I'm always amused at that by comments on online when you post something about either concrete or like radiant floor systems, and people say, well, how do you repair a leak? Well, maybe the idea is that we're building without leakage.
Well, and if we're going to do that, then how do you repair a leak for your water line that runs underneath there that supplies your shower?
Sewer in the street or whatever the case is.
Sometimes it sucks.
Yeah, you have to fix it. But yeah, and I mean, it always, things like this, it kind of starts with what was that end game? Like, as we look at these details, is there a way we can take that concrete out of it? Right. And that's kind of where that started, but not exactly. My first.
Wait, so if you're about to go to history behind this, right?
I'm opening the history book.
I'm going to go 2,000 years before when you were about to start.
Okay.
Buildings in ancient Rome.
This piqued his interest all of a sudden.
While the Romans...
We're not talking about your birthday either, but we're just...
Why is it when you say something like that, I smile and laugh, and when we say something like that to you, why is everybody always picking
mine is a funny intellectual joke. You guys, it is an insult. So that's the difference.
I'm not sure if I agree with that, but okay.
Well, see, there you go.
So,
of course you're not going
to. 2,000 years roughly before your history that you're about to start with.
So you're basically talking about like the
ancient Rome.
The sunrise of AD.
Sure.
Okay.
Yeah.
All right. Just making sure we're on the same timeline.
50 years before that, too.
50 years before.
500 years before that. While the Romans had figured out concrete, they were the first ones to figure out concrete. In fact, we lost the ability to understand concrete for like 1,500 years there after the Roman Empire fell, by the way. Thanks for yawning. Yeah, exactly. Nobody knew how to repair it. Nobody knew how to replace it.
The one guy with the building science knowledge died. And he forgot to write it down for everybody else. So, hence, the podcast, making this information in perpetuity. So, 1,000 years from now, somebody's going to be watching.
I had no idea why we were doing this podcast.
Exactly. It's 1,000 years from now, people are going to sit there and say, I remember that Peter Yost. He wore that orange shirt right around Halloween. And
SK Collaborative, our good friend Carl Seville from Atlanta, Georgia.
I like Carl. So I'll promote his shirt. Good job, Carl. Thank you.
So the first buildings that used concrete didn't use it as a floor. They used it as a foundation. They used it as a building material. The Parthenon is concrete. The floor is not a concrete floor. The substructure is compacted aggregate, sand, and tile.
Or stone.
And actually, now that I say that, the Parthenon's stone instead of tile. But
yeah, I was just going to say, I was in a 2,000-year-old Roman structure about 2 months ago, and it was all stone and brick, and the walls had mortar, but the floor didn't.
And so we can make an argument that, done correctly, potentially we're talking about a multiple thousand of year assembly that I might be stretching it a little there, but you get the idea.
I think it starts, for me, is what are we doing and why are we doing it, right? And if the answer to the second question is because that's how we always do it,
right,
then I think we need to rethink it. That's to me, that's a cop-out, right? Now, it's okay if you say, well, that's how I always do it, and I find that to be the most economical way to solve that problem.
I've already thought critically about it.
I've already critically thought about it at some point. But to just become a builder or an architect or something and just do what we've done for so long doesn't help our industry, doesn't help you.
So are you thinking of the floor assembly as simply a material choice? Is that pretty much what you're saying?
I think of everything as a choice. Yes. So there's a material choice there. There's a process choice.
Cost.
There's a procedure of how this gets installed and what goes on top of it, what other things are attached to it in the assembly. Because honestly, that's where a lot of this started. It wasn't like, should we do a concrete slab or not? It was driven by what was happening long after the slab would have been installed, which drove some of these questions, I guess, is my point.
But we're talking about slab-on-grade homes just because that's the term we use for them.
Yeah.
But without a concrete slab.
Without a concrete slab. But what I was saying is before we get into the project that Jake and I did, I wanted to give a little history on where that innovative idea came from, because I have a number of
So Jake dragged
steps.
us back to BC, and you're bringing us back to
I'm just bringing
AD.
us back to 1999, year 2000, something like that.
Okay.
So it started. I was remodeling my house. My wife and I had bought a slab above grade Cape Cod style house north of Boston. So it was, every floor in the house was a concrete. You peel up the carpeting or whatever, it was all concrete floor. So it was either tile or carpeting in the house, but we wanted to put hardwood floor down. So how do we get from that concrete slab to a hardwood, right?
Sure.
'Cause everything else goes down easy over the slab. This didn't. And there were still the remnants. It had an in-floor ducted HVAC system. And it was abandoned at the unit and switched to a baseboard system, but all the ducts
Any
were
number
still
of reasons.
for any number of reasons, but the ducts were still in place. So I peeled back the carpet, filled up all the ductworks with concrete and such. But the idea comes is it's not so much in just like the initial question was, the end game was we wanted a hardwood floor. How do we get there? Now, we could have just nailed down sleepers to the concrete slab floor, put a hardwood floor across the sleepers. Voila, I got a nice hardwood floor in my house. But the problem was a couple things. One, the concrete slab in this particular house wasn't flat. It actually was a little higher at the ends. And so how did we level that? And how do we do that? So a little leveling compound, and in talking with Joe, because I was working at Building Science at the time, Joe Stiebrick, and he said, "Oh, this is an easy one. You just put down some rigid insulation, and we'll put a couple layers of plywood above it." And I was like, "Couple layers of plywood?" He goes, "Yeah, you just take the plywood and laminate it, cross over the joints, and kind of build like a giant raft in the room."
So you're offsetting the seams in the plywood, and then you're also changing the orientation of the way the
Changing
sheets
the
run.
orientation of the board.
So there's very little transposition of
So we took 2 layers of 1/2-inch plywood and made 1-inch thick plywood. We just site constructed it because we moved the joints around and all of that.
which 1 inch by itself, that wouldn't work. You just
Which
have
1
pieces
inch
of
by itself,
plywood
you'd
that
have
can
pieces
move
of plywood
independently.
that the joints move. Now, and I put that over, we put it over 2 inches of XPS, which I probably wouldn't do if I was doing now, but at the time XPS
Why?
seemed...
Crush factor or
No, it's just probably not as environmentally friendly as some other insulations.
You could have used an EPS that was the same
Could have used-
density.
yeah, and
or
then
a
make an
GPS
or a
today,
GPS.
graphite polystyrene that's
Yeah.
even better for the environment.
All of those, but it's not necessarily the worst thing, but it probably isn't the best choice. But anyways, that wasn't the issue. The other issue that I found when we were doing it, I only used 2 layers of 1/2-inch plywood, so I ended up with some soft spots in the house. And then thought, okay, how do I solve this? Well, the solution was actually quite easy. I went and got 4-inch concrete nails. And whenever I just walked back and forth, did like a little sonar review of my floor, when I felt a soft spot, I drove a 4-inch concrete nail through the whole system into the slab. And so I kind of stiffened it at that little
You gave it an
micro.
anchor point.
I gave it an anchor point. Now, I've heard guys, oh, you can use Tapcon screws and this and that.
Same stuff.
My 4-inch concrete nail worked fine with a little 4 or 5 pound sledgehammer.
Persuader.
Yeah, little persuader. And it went in there. And it's been in place for, 20 some odd years now. And it's gone perfect. But that set up a system in my mind of, with slab on grade or concrete slab houses, how do we deal with stuff that's happening above it?
So in the assembly you just described, there was a concrete slab insulation in the 2 layers. So we have still a slab, but now it's insulated, and we
Right.
resolved
It was a
some of those
retrofit.
comfort and,
Right. I didn't ask the question about the slab because the slab was there.
yeah, it's not like you were taking it out.
And you must have had total havoc at all doors in terms of...
Well, we were doing the downstairs, and we were doing it in 2 phases. So we were doing the kitchen and dining room kind of space at that time. And when we did the bedrooms, yes, all the bedroom, but they were all non-load bearing doors, no headers,
So easy to
and all
change.
that. So yeah, they all moved up 1.5 inches or 2 inches, whatever. No, in this case, more like 3.5 inches.
You know what's kind of interesting about this is I've stayed at your house many, many times. Never even... I didn't even know the story, nor did I ever notice that.
Well, one of
this
the other
process
interesting
happens.
things that we did there that too, and I don't want to veer from this too much, but it's quite a neat thing is Joe had also suggested, hey, you're putting in the flooring, you should back poly all the hardwood floor. And I did. So I set up a couple horses, a tray. It was really quick. I mean, and I don't know, it was probably like 1,200 square feet of hardwood flooring, but a little mini roller, and in a couple hours, I had it all back polyed. That floor doesn't move seasonally at all. I don't get any joints. It doesn't open, close. It is stable as ever.
Interesting.
But anyways, that was my first encounter of working with a slab on grade kind of retrofit that would drive future questions.
Yep. And you and I have even built one like that.
Yes.
The hybrid house where we have basement over part of it or under part of it, and then slab on grade everywhere else. Clients weren't necessarily keen on getting rid of the slab. They were a little concerned. And then you throw in the basement, it probably makes sense to go ahead and pour the slab. So what if we want to get rid of that slab? What if we want to build the house without the floor?
Yeah, so that drives when you have the ability to have new construction and you go through and question every assembly. Like I said, sometimes you sit there and say, yeah, we'll just do that like we did the Joneses house or whatever. But occasionally you sit there and say, okay, if it's a concrete slab assembly, my end game is a wood floor. Then I have to put in a slab. I'm probably going to put in some sleepers. Then I have to put a subfloor. Then I have to put the finished hardwood floor on there. That's a lot of steps, a lot of layers. And is there a way around it? Is there a way to improve it? And the first question was, do we really need the concrete slab? What is it doing besides providing some type of hard substrate? And I know there's people out there who say, well, if you get good compaction underneath there and this and that with the slab's going to make sure, the floor doesn't move. I mean, I think all of us have probably been in buildings where we've seen, slabs subside or crack or something.
Heave or not be flat in the first place.
We've excavated slabs in basements, like taken them out and found like 2-foot voids underneath some slabs where the ground just kind of washed away from underneath it. So, this whole idea of, you need a slab structurally. No, I don't buy that you don't need it structurally to hold the ground up, because if I do everything under the slab correctly, then the slab is just kind of a non-supporting piece of the birthday cake, right?
Sometimes we talk about, like in a crawl space, a rat slab, and the idea there is, well, we need something to keep critters out. So that's, I mean, to me, it's like, really, we're going to pour an entire concrete slab just for rodent control or pest control?
And I think that's kind of one of those myths, but it's like we pour the slab there just because we can make it so we can crawl around there and not have to crawl around on dirt or stones or poly or something. And we use the term rat slab loosely. That I think its birth was in this idea of making sure we don't get animals tunneling into it. But yeah, rat slab is a very loose term, but I'm with you. I'm with you on that one.
And so if we take away the concrete slab, what do we use to replace it?
So if you take away the concrete slab, then we just have to, the compaction and everything that's happening under there, I think is the same, right? Because why would that change? The structural effort to support that floor, the concrete wasn't really adding to it.
So in other words, we have hopefully in undisturbed soil that already is a great compaction, or we have engineered compaction underneath of this. We have some sort of aggregate that we can rake out and that we can level. And in the instance of the one that you and I built, which I think is hashtag Prairie House Arrow on Instagram, if you want to see it, we'll make sure we link to that. We then went to lime waste as our top coat, the same way that you might do like a paver patio. That gave us the ability to rake around, fine adjust, fine tune, and make sure that we were perfectly flat. And then we compacted that, and we compacted it two different ways. We used first a large, like walk behind industrial compactor with a sheep's foot that really took care of any issues that we had. And then we used a hand compactor and a little bit of water, because that lime waste, you can rake that around really well and make it really quite hard. And then you can not worry about walking back and forth.
Yeah, the very first one I did, the contractor came back, and one of his criticisms was, we got to find a way to use something other than just 3/4 inch stone to level. He goes, our shoulders are dead trying to rake 3/4 inch stone to a level platform.
Yep.
Well, when you think about it, one of the cool things about making a concrete slab is how easy it is to level.
And I think
part
that's
of the process.
That's part of it is that, it's this very fluid material.
I don't know. I don't know if I've ever
seeks
had one
its
that
own-
was
No, but I mean,
perfectly level.
I totally agree. Not perfectly
seeks
level.
level on the bottom side.
Yeah.
Then they fiddle with it, and it's got high
But it's
spots.
easier than raking 3/4 inch
it
stone,
is.
I guess
It
is
is.
the point.
And we
So-
should point out that while we're talking about eliminating the floor, we didn't eliminate any structure around the exterior. We still basically have a footing with a stem wall so that the building sits on that. If we had load-bearing points on the interior of the building, we could have a point load that goes down to a concrete pier that all this sits around. For the instance that you and I built, it was all trussed, sitting on all exterior walls. There was no interior load-bearing. And before we get any further, I should also say I was back there, and I think I told you this, I was back there a few weeks ago. And that house is 3 years old now?
Yeah, every bit
And
of it.
they have absolutely no cracking. There's no paint work that's even cracking, like on the trim and millwork. There's been no movement in that house whatsoever that's perceivable. And they're slightly picky. They would point it out if we had issues.
You know, the key here is that we're talking about when to use concrete or not. And when do we need to use concrete? Because of the compressive strength, or as an environmental separator. But we're going to talk about permanent wood foundations and, in light frame construction, the loads that you're trying to transfer are pretty small.
Yeah, I mean, there's not. I mean,
We think about it as being heavy.
that's because we associate it with us lifting that beam into place that
Right.
carries that floor
But the
load,
loads
and
are
it
actually
is.
really slow.
But in relative to nature, it's
And to commercial buildings.
And commercial buildings, it's like one column in the middle of a skyscraper is handling more weight than the whole foundation wall of this house.
I don't remember the exact math, so this is going to be just
Go
hyperbole.
ahead. If I think it's worth laughing at, I'll bash it.
We built an addition to an auto garage a few years ago, and
What's an auto garage?
A service bay.
Auto garage. Okay.
Not like auto. It
I thought
wasn't
you
built
said
for
OTTO,
auto.
right.
OTTO.
Like
Okay.
Auto garage. I was like, auto got a garage.
And the owner was very concerned about the car lift, what kind of load it was going to cause, and whether or not there was going to be cracking or anything like that. And we ran the math, and it came out to something ridiculous, like 60 PSI or something like that. Like the load was spread over 4 posts.
Yeah.
The post had a point load of like a 16 by 16. And then it was like, even with my truck on it, it was still 60 PSI.
Well,
or something. And I was just
20,
like,
the
you gotta be kidding
EPS
me.
that's rated for 25 PSI, it comes out, it's like 12 or 1,300 pounds per square foot or something.
Yeah.
Right. So it's because it's 25 times 144. So my phone's off, but do the math. It's, you sit there and go. We actually did a test at, who's the guy? Mark Sevier at Building Science, because we wanted to see if you could crush foam. So in Building Science in the back barn, we had a bunch of different rigid insulations, and we stacked 8 high concrete blocks on it. And then we'd go back there and peel them off to see how much did it indent the foam. So that was one of my very first wing nut.
Here.
In the back.
But the whole point is, these are small loads that we're talking about.
Yeah.
If we're not doing this in
Do you
challenging
want to hear the
assemblies.
coolest anecdotal story I have about
I
lifting
can't
a
wait.
car? In high school, as a joke, my friend had a Volkswagen. So 4 of us, we got a bunch of blocks from wood shop. We went out, we lifted we literally, I don't know, it's probably 5 of us, lifted his car up on the back, and then somebody put the blocks in. So his tires were literally maybe a 1/4 of an inch above the pavement. So he couldn't see it. So he got in and started up, puts it in gear, hits the gas, and the tires are spinning, and he's like, what the hell's going on? Why am I not moving? Because we had his whole car
Are those things
up on blocks.
rear-wheel drive? Surely, for mechanical reasons, that's a rear-wheel drive.
Yeah, but the engine is back there.
Yeah, so you guys picked up the back half that also had the
back half,
engine in it. I hadn't thought about whether or not a Volkswagen Beetle was rear wheel or front
but it
wheel
wasn't-
drive before.
It wasn't that heavy. But anyways, but
There's
small
definitely
loads.
a heavy end and a light end. to
Yes,
that
there is.
car.
This is becoming a very heavy conversation. That was kind of weak.
Agreed.
Recognition is the first step.
It is.
Admitting you have a problem is step 2.
Well, I just want to say,
you're past that
I
point.
can't believe I'm going to glad hand you like this, Steve, but one of the things I love working with you about is you as an architect, you are constantly saying, why am I doing that? Is it because that's the way it's always been done? Or is there an underlying reason that makes it a constraint? And it's funny because you oftentimes turn things into a design problem, like tell me what the constraints are, and I will design around those constraints.
Isn't there some ancient proverb or something? I'm being serious here, but it says like the greatest opportunity lies in the most difficult hardship, or there's something there that hardship
we can
creates
pretend like that's
opportunity.
That's pretty well said too.
There's something there, but there's a lot of opportunities when you're trying to understand what that end game is. So we sit there and go through it and say, well, we want a hardwood floor, and the hardwood floor needs to be supported on some type of sheathing. That sheathing needs to be supported on something, and we need some type of insulation layer to complete our control layer. So where is the slab required?
Yeah.
Right. And is it required? And the answer is, well, as we found out, no, it's not required. And I've been in that house also a couple times after post occupancy. The thing that I love about it, I can walk around it and I can feel the floor giving a little bit. And it's that whole, let's get rid of that concrete slab discomfort.
Which is not a bad thing, the fact that it oscillates a little bit under
I
pressure.
mean, that little give that I'm saying is that's what you want to experience.
And Steve, when you design homes that are slabless like this, do you intentionally clear span from exterior wall to exterior wall so you don't have to do a footing in the middle for a post?
I've done a couple where we would have a footing, but then all we do is we take the 6x6 post or steel lolly column or 3.5-inch steel column. It just goes down to the footing, and the whole floor assembly just wraps around it.
Yeah.
Now, what's interesting is that takes us to a kind of a slight turn, because I worked on a project and they were, people sit there and say, well, is there any way to isolate that column from the ground and insulate it? And we did. We found, I can't remember the name, but there is an extremely dense foam. But it was extraordinarily
What are we
expensive.
chasing at that point?
And that takes me to the point of one of my favorite sayings. Something has to be the worst part of the house, right? Mm-hmm. And if it's the column going all the way to the footing in the middle of the house, I'll live with that.
I had a client just last week say to me, really? What is the heat loss if you have a 40 by 40 square? What is the temperature?
But it's even not the 40 by square. It's a 4-inch square.
No,
Because
but
the
I'm saying
footing
if
is
that's in
under
the middle of the
insulation.
building, even in a cold climate, what is the delta T in the middle of winter right underneath that post? I honestly don't know the answer to that question, but yeah, it's
Not
probably
what it is outside to inside.
The delta T there is probably
15 degrees, 20 degrees at most.
I wouldn't be hard to, with an infrared camera, go and figure that out.
Yeah.
So the one thing that we didn't talk about in this assembly is a vapor barrier as well. Mm-hmm. I will tell you that we've done this assembly twice, once on top of a slab, once without a slab. The time that we did it on the aggregate, the compressed aggregate, we put down the poly first as our vapor barrier, taped all the seams, taped all our penetrations, then foam. The foam wanted to move around a little bit. And it was a little bit of a pain. Like,
a little too much
you
of a
step on the
slip sheet
poly,
with
the poly wanted to move a little bit, and then the foam wanted to jiggle around. Once we got it all in, it wasn't horrible or anything. But the second time, we put the poly on top because we had that concrete there, and we didn't want concrete and poly and that slickness to happen again. And then it took about an hour of them starting to install the panel to go, oh, wait, we're punching a ton of holes in this because we're using 2-inch screws instead of 1.5-inch screws. Now, we didn't go back and repair any of it. I think that the risk there is super low. Mm-hmm. And I'm not sure which way I would recommend doing it, but what I'm bringing up is don't forget the vapor barrier because you are coupling to the ground in some way or another.
Did you use the builder grade is 6 mil poly? Did you intentionally use a heavier?
No, we use 6 because, so if it's a basement and we're going to pour over top of it and they have to like place rebar and everything, we use something heavier because they're going to be walking all over it.
Right.
In this instance, we knew that we could roll out the poly and then immediately start putting the foam over top of it, and the foam would go way quicker. We weren't dropping things with sharp edges, things like that. And we were like, we can.
Is there a perm rating? I don't know. Is there a perm rating difference between 6 mil and 10 mil poly?
Well, I'm sure there is because it's always related to thickness, but you're already down at 0.6 perms.
Yeah, it's pretty low.
It probably
already.
drops down to 0.4
It's like
or
the
something.
difference between being 20 perms
But
and 25
the
perms.
perforation is what we're worried about.
Right.
Them
No, I
walking
get
on
that.
gravel.
I get that. I was just
Well,
wondering.
and interesting, the perforations from a vapor movement, quite different than if we're talking about the penetrations in liquid water, which brings me back to, so when you do buildings like this, we of course have already looked at site, groundwater table, that. So
We've
eliminate
assessed
that.
the risk from a
Yep.
water management perspective.
And then one more quick question. What about building inspectors? I mean, I can, there's always two problems with building inspectors. What's the code? But then what do they think the code says?
Okay, so it's not in the code. Nowhere in the code does it say that you have to have a concrete slab, which was the first conversation. And then the one that you and I worked on together, the Prairie House, the next conversation was, okay, I need something from the manufacturer saying it's okay that you can do it like this. And I was like, dang, he got us. Now we got to go to them.
Who's the manufacturer? I mean,
Well, in that case, the EPS has a crush rating printed on it, which is fine. And then we went to, in this case, we were using Advantech. We went to Huber and said, we need to know that this meets the load calculation.
Yeah, the first time I did it with Huber too, I went to and talked to Chris Vegas. but
fantastic on their
their
part.
engineers, and they were just super helpful. And their first thing was like, we never even thought of doing this or having this problem, but let us check it out.
Yeah, they want to
but
get
what-
behind it. Let's
but
sell
what
2
did you
layers
need-
of subfloor.
What did you need to get from manufacturer? Compressive strength? Was that the only
So
thing?
what we needed was, what we got from them was a gluing and screwing schedule. And that if we did it in this design parameters, that they would be okay with standing behind it from the L over 360 rating or whatever.
Oh,
we're shooting
okay.
for.
Yeah. So it's not only compressive, it's deflection.
Yeah.
That's really interesting.
Which was great because we went to them and all this happened before we started building. And we said, okay, we're going to do this. There's going to be tile. I need to know that the load rating is going to be okay. And then we took what they had to say about it to Schluter that makes our waterproofing and our crack prevention membrane and said, are you guys okay with this? Are we voiding the warranty? And they said, no, you're good.
And that house has a bunch of tile.
It does. It has tile entryway. It has a tile kitchen. It has 2 tile bathrooms, a tile shower, a recessed
and there's
space.
zero.
No problems whatsoever.
And you've got the concrete perimeter.
Yep.
So in
Where's it
terms of
going?
wood 8 inches separated from finished grade, you don't have any wood that's out
Yeah.
at the perimeter.
Yep.
And it's
Very
fully
interesting.
insulated because we use 4 inches of EPS
Yeah.
foam there, which I like because when you talk about continuity, which is one of our favorite words, I mean, this is everything inside the exterior wall, foam on the floor.
You know what we need to do? We need to go and do.
I often wonder what I need to do. I'm glad you're around to tell me.
That's why I'm here.
I believe it.
We need to do some infrared camera work and do side-by-side comparisons with the Delta T.
Yeah,
That would-
man, that's wicked cool.
I think he's being facetious.
Man, you cut me to the
Potentially.
quick, brother.
He got all excited that you were in agreement with him and then realized what was happening. You could see it wash over his face.
Keep reeling them in. Come on, baby. Let's get you close to the shores.
You should be ashamed of yourself.
Listen,
You know, you just
pretty much
backhanded
everybody
me.
I've met in my life has told me that.
You should reconsider existence.
I'm going to go talk to Steve Williams about infrared images.
All I'm gonna tell you is you
I'll
miss
get
me
the
when I'm
appropriate
gone.
reaction. Yeah.
So, the point of this is there can be a different way. Think about
There
it.
can be a different way, and I think,
And it
that-
might not work.
And I think the true point of this is not necessarily the fact that we were able to build this house without a slab. It's how as builders, architects, building scientists, and the like in our industry, how do we move our industry forward? And what kind of questions should we be asking, and how should we be asking them? And what should we be thinking about?
Which,
Right.
if that's not clear, is it's not necessarily that this is a solution for you for some sort of problem. It's think about your problems differently.
Think about it.
Think
Don't
about
just go
everything
build it
as a potential.
today. And it's sad because probably the majority of our houses built don't have the opportunity to migrate, right?
Mm-hmm.
When you think about, I don't know, 1.3 million building permits a year, I think it is, something like that.
In a strong year. Yeah,
in
sure.
a strong
Yeah.
year, right? What percentage of those are like production style homes versus a custom home that has the ability to migrate? You know, they have their system set up. Okay, go. And just, I mean, when I was with, Artistic Homes, we were in the heyday, we were framing 20 houses a week.
You wonder,
It's just-
though,
it's
Steve,
crazy.
that you're describing this as perhaps a system change for custom builders. Production builders should certainly be looking at the differences between
Yeah, because
slab and slabless.
if that changes if that moves the needle $1,000 times 20,000 homes I build this year, that's a big change in that bottom line.
Or even just timeline, even if it costs the same, which we should real quick talk about cost.
Well, I think cost, but the other thing that comes to mind is, we talk about it not being as hard and not having any problems. In some ways, I would argue that this system makes for a better warranty on the system, right? It's like
I've had no callbacks.
with Joe. I remember we went out to Lincoln. I think it was Lincoln Homes, and somewhere out by Prairie Crossing, and he went out there. They were having all kinds of drywall cracks, and the answer was, Joe said, "Well, you're attaching your drywall far too much to the wood frame."
And when I first heard that from Joe, I was like, of course we're attaching it. The more you attach, the more control you have.
Right,
Which is
and that's what
exactly-
people think.
Yeah.
Oh, well, you don't want that
Still.
to crack. I'll just put in 50
More
more screws. But the reality is that you want to take 50 screws out of that assembly because you want it to be the most flexible it can possibly be. It's cracking because you're restricting movement.
And the key to this is that's the engineer in Joe saying that you think you need to stop the movement when what you should be saying is, how do I let it move? The opposite
It's
question.
asking the right question. And I think that's what the Unbuild It podcast is all about.
So just real quickly, in all these homes, there are people that run ducting and plumbing. I've never heard any wiring in slabs, but for this approach, you're not putting anything in the slab.
You know what the beauty of this
Yes.
this system is too?
I can't wait to see the beauty of this.
Right, and because this is a huge problem with slab on grade houses. You get to wall framing, and the plumber comes over and says that wet wall's over 2 inches from where my pipe is. So, do we move the wall and all the framing, or do we move the pipe? Well, if we move the pipe, we got to hammer out the slab. And yet you can't hammer it out to where you're moving it. You have to hammer it out to deconstruct what's there. To slide it over. What do we do at a house that's just foam? You carve out the foam, you move the stone a little bit, you extend the pipe, you put a little more stone back, and then you just spray it with expanding foam.
So another advantage is, what's the word I'm looking for? Not changeability.
Adaptability.
Maybe adaptability or something along those lines.
But that ability in wiring, the other one that always comes up that we have major problems, if you're trying to hit a wall at a kitchen island. Right?
Oh, yeah.
So you get there. In this system here, you can just cut a channel.
Yeah, I was going to say router.
Router it out, drop the wire in underneath the flooring.
We had floor plugs and the island plugs at that house. And obviously we had some wires that ran to interior walls that wouldn't be easy to get to from above and things like that. What we did was the few of them, when they dropped to slab, we took the circular saw, set it at a 45, cut a V, and then we laid metal conduit in so that whatever we screwed in was unlikely to ever hurt that.
I would never have thought about that, but boy, that's a huge advantage.
Yeah, you can go in, and some
And
of
all
these
the
things
plumbing's just below in the aggregate, just like it would be in a slab. None of it's caught in our assembly; it's just below it.
And we'd like to think we're going to plan and catch everything, but
Yeah.
you still get
Yeah.
the client that says, hey, I never thought about it, but can we put some outlets in the floor in this room?
Right.
Yeah, we can now.
So cost wise, on the first one we did together, we were slightly more expensive, I think, than doing concrete. I think having learned from it some now, we probably would be a wash or cheaper. So I think it's definitely something that we would consider again. And if you want more information on that house in particular, Pro Tradecraft did a 10-part video series.
Yeah, they actually won an award for those
Yeah.
videos and stuff on that.
for educational content, for instructional.
Dan did a beautiful job on
Yes,
that.
he did. Shout out to
Kudos
Dan Morrison. So you can find that on Pro Tradecraft. And I think, Reisinger did a tour with us
Yep.
of the house, but it's post-construction, so you can just see what the house is like.
And Dan, just a quick plug for Dan Morrison, who was the co-creator of Green Building Advisor before he ended up at Pro Tradecraft.
Dan's just a great guy. I mean, we'll give him his 2 minutes of fame. On the Unbuilt
Can we take a
podcast.
weird stance on it and see whether or not he listens?
He will now.
Yeah, well,
I'll go tell him. Give it a listen. But even I don't care if he listens. Dan does a good job for the building industry. He is certainly an asset to the
And
industry.
passionate about the industry as well.
So kudos to Dan.
Okay. Thank you for watching. If you're watching this on YouTube, thanks for listening on whatever device you use to listen to the podcast. We enjoy making this. We're thankful that you're here. We love your feedback either through the Unbuild It
I
podcast.
don't understand if I'm really happy to be here.
Okay. We'll let him ponder that. We like your feedback either through the Unbuild It podcast on Instagram, or by all means, leave us a 5-star review on Instagram or on iTunes, and leave a comment. Click the subscribe button on YouTube. The more people watch, the more of these that we have the ability to make. So
I'm going to end it with a Pete joke. Pete, and this is a joke to Pete. How do you make a hot dog roll? Put it on a hill.
Wow.
Until next time.
And if you're trying to communicate with me, the best way is to just send me a letter in the mailbox.
Pony Express.
thank you guys. Have a good day.